lawnmower 2,500 RPMs means revolutions per minute. We're just going to simply at this point change this to radians per second. Okay, so I'm going to start by writing it this way. 2,500 revolutions per minute. Be really careful with where you're putting your different units. So instead of writing it RPM, revolutions per minute, I'm writing revolutions on the top and minutes on the bottom. Now I want to change revolutions to radians. How many radians are in one revolution? I guess we should have added that to our other little list we were making. 2 pi. Right. So 1 revolution, you can add this to your little list if you need to, is also 2 pi radians. Correct? Because all the way around one circle is 2 pi radians. We just learned that in section 1.2. Huh? This is if you want to change from revolutions to radians. When we were just barely talking about it a few minutes ago, it was changing revolutions to a distance, like inches or feet or miles. And to use that one, you have to have a radius. This one doesn't require a radius. Okay. So 2,500 revolutions per minute. So to change revolutions to radians, what am I going to do? 2 pi radians in 1 revolution. Okay, what else am I changing? Minutes to seconds. So minutes is on the bottom, so that means I want minutes on the top and seconds on the bottom. So what numbers are going to be involved in that? 1 minute and 60 seconds, correct? So in your calculator, you're going to have to do 2,500, oops, that was too many zeros, times 2 times pi divided by 60. And our minutes cancel out, our revolutions cancel out, and we should be left with radians per second. Okay, so throw that in your calculator for me. 261? Okay. So 261.8 radians per second. Could you also leave that in terms of pi? You could. So try doing this for me. Just do 2,500 times 2, so that's 5,000 divided by 60. Now what do you get? We still get a decimal. Okay, so it might be best to leave it, what is 8.33? 25 thirds? Is that right? So you have to pay attention to whether they want you to leave the answer exact, like something like this, or leave the answer as a decimal. Okay, so the instructions will usually say how they want your answer left. Okay. Here's another formula, but honestly, I don't use these formulas as much as I just use conversion factors. When I start trying to use the formulas, I get confused. So the stuff we've been doing with conversion factors is going to be the most important thing. Linear velocity, we're going to use a v. And linear velocity can be found by taking s divided by t. And s represents arc length. And t represents time. So officially, there's a formula to find linear velocity, but like I said, I prefer to just keep using conversion factors, and especially using the one I told you earlier. I'll just review it one more time, which is 1 revolution, which is 1 circumference, is 2 pi r distance. Because imagine a tire with a certain radius, and how far is that tire going to move forward if it turns around once? It's the circumference of that tire, right? So that's how we change angular velocity to a linear velocity. Okay, let's do one more example of this, or one example of this. We haven't done any yet. Here's an example. Oh, and I guess we might end up needing the formula S equals AR if you want to, or alpha R if you want to try doing it that way. Okay, imagine we have a propeller on something. What types of things have propellers? Like a helicopter, maybe? I have a propeller that has a radius of 1.2 meters. Does that sound reasonable for like a helicopter propeller? 1.2 meters, that's pretty long, right? I don't know. Huh? Ooh, you know much more than I do about this. Okay, and this propeller is runs at 1400 RPMs. We want to change to this and find out how far or how fast those propellers are traveling in a linear velocity. So in other words, the end of the propellers, how far are they going in a certain amount of time? Okay, how much air are they cutting? That doesn't seem like as practical an example as some others that I've seen, but oh well, this is what I have written down, so we'll go with it. Okay, so we would start with 1400 revolutions in a minute. Now here is where this comes into play. What did we say one revolution is? One revolution is 2 pi r. So 2 pi, and what's r for our propellers? 1.2 meters. So that is the circumference of those propellers for one revolution. Okay, now I forgot to actually tell us what we were changing it to. I changed to meters per minute. Okay, so I changed the revolutions to meters, but then do I need to change the time unit as well to hours or seconds or anything like that, or do I just leave it at minutes? In this case, we leave it at minutes, but you would have to normally pay attention to that and see if you need to do some sort of conversion for the minutes as well. In this case, no. All right, so then we just take our calculator, 1400 times 2 times pi times 1.2, and that will give us our meters per minute. And let's go ahead and do a decimal. Don't worry about it leaving it in terms of pi. So just throw that in your calculator. What'd you get? How fast are the propellers moving through the air? I have 556. Does it round up? Meters per minute. Okay. I have another formula written down here which has to do with what we just barely did, but I like the way that it hurts my brain to try and think through the formulas instead. But let's compare this to what we just did. Linear velocity v can equal r times omega. So velocity is radius times omega. Does anybody remember what omega was again? Omega was radians over a certain amount of time, correct? Well, what we just did here was we took the radius, which was 1.2, and we multiplied the number of radians per time in minutes. Because it started out as revolutions, but by multiplying the 2 pi, we're changing it to radians. So 1400 times 2 pi is changing it to radians per minute, which is omega. And then multiplying by the 1.2 meters is multiplying the radius r, which gives us the linear velocity v. So do you see what we just did really was using that formula? It's just that it's easier for me, instead of stopping to say, what was that formula again? I just use conversion factors. And then it always turns out right. So while I've given you formulas, I think the power in this section is not in knowing the formulas, it's in knowing how to use conversion factors. So. Okay, so it can be a little tricky. You'll be okay.